Hey everyone, and welcome. Today, we're going to pull back the curtain on Java. We're going to figure out what's really going on behind the scenes when you run a program. And we'll do that by breaking down three absolutely core components that make it all happen: the JDK, the JRE, and the JVM.
All right, so let's get right into it. You've spent hours, maybe days, writing your awesome Java code. You finally hit that run button, and poof, it works. But, it kind of feels like magic, right? What is that magic? What's the actual chain of events that takes your code and makes it do something real? Well, that's the mystery we're going to solve together today.
Okay, so we're going to start with the biggest piece of the puzzle and work our way in. First up, the Developer's Complete Toolkit, the JDK.
So what exactly is the JDK? Well, it stands for Java Development Kit. And really, it's the whole shebang. It's the full software package that you as a developer need to write, compile, and even debug your Java applications. I always like to think of it as the ultimate all-in-one toolbox for anyone who's building stuff with Java. Okay, so if it's a toolbox, what's actually inside? Well, you've got all the essentials. You get the Java compiler, that's Java-C, which turns your human-readable code into something the computer can start to understand. You get debugging tools, which, let's be honest, are total lifesavers. You also get a bunch of crucial libraries. But, and this is super important, look at that last item. The JDK actually includes the entire Java Runtime Environment, or JRE. Now hang on to that thought, because it's the key to understanding how this all fits together. So what's the JDK's most important job? Well, at its core, it's all about this one transformation. It takes the Java code that you and I can read and write, and it uses its compiler to turn it into something called bytecode. Now, this bytecode isn't quite the ones and zeros your computer processor understands directly. Think of it more like a universal intermediate language, a set of instructions that any system that understands Java can read. All right, let's peel back another layer of this onion. We're moving on to the JRE, or as I like to call it, the user's playground.
The JRE, that's the Java Runtime Environment, and the key word here is minimum. This provides the absolute bare essentials that are needed to simply, run a Java application. It has the core libraries and, most importantly, it includes the Java virtual machine. This is what your friend who just wants to play that cool game you built would need on their computer, not the whole developer kit, just the JRE.
So, to put it another way, if the JDK creates a script, that bytecode we talked about, the JRE is the stage where that script can actually be performed. It sets everything up, providing all the props and background scenery. The class libraries and support files that your code needs to call on to actually do its job. And this right here, this is probably the most common point of confusion, so let's make it crystal clear. Who needs what? It's simple. If you're a developer, if you're the one writing and compiling the code, you need the JDK. But if you're an end user, someone who just wants to run a program, all you need is the JRE. So building the application, JDK. Just using the application, JRE. That's the big difference. Okay, time to zoom in one more level, right to the very core, the absolute heart of Java itself, the JVM.
So the JVM, that stands for Java Virtual Machine, and it really is the engine that makes the whole car go. Now, it's not a physical thing you can touch, it's an abstract or a virtual machine, which is basically a clever piece of software that pretends to be a computer inside your actual computer. And it's one single purpose: to take that universal bytecode we've been talking about and actually execute it. It's the final piece of the puzzle. And this right here is Java's superpower. The JVM is the reason you always hear that famous slogan, write once, run anywhere. It's not just marketing, it's a reality because of this thing. Think about it. You write your code once. The JDK compiles it into bytecode once. And then what? Well, there's a specific JVM built for Windows, a different one for Mac, and another one for Linux. Each of these JVMs knows how to take that exact same bytecode and translate it into the native language that its own operating system understands. It's like a universal translator, and it's what gives Java its incredible portability. Absolutely brilliant. All right, we've looked at all the individual parts. Let's step back for a second now and see how it all fits together in the big picture. This is probably the best way to visualize it. I want you to think of those Russian nesting dolls. You know, the ones that fit inside each other? At the very, very center, the smallest doll is the JVM. That's the core engine. The next doll up, which holds the JVM inside it, is the JRE. The JRE is the environment, and it has libraries plus the JVM. And then the biggest outermost doll, that's the JDK.
It's the full developer toolkit, and it contains all of its own tools, plus the entire JRE. See, it's a layered system, where each one contains the next.
Okay, let's do a super quick summary to really lock this in your brain. Just remember the main verb for each one. JDK, the development kit, is for, you got it, developing. JRE, the runtime environment, is for running applications. And the JVM, the virtual machine, is for executing the bytecode. Develop, run, execute. If you can remember those 3 words, you've got it. And this quote just drives the whole point home perfectly. Every single time you, as a developer, install the JDK, you are automatically getting the JRE and the JVM right along with it. You don't need to install them separately. Remember the nesting dolls? When you grab the biggest one, you get all the smaller ones inside. It's the complete, all-in-one package. So there you have it. You now understand the what, the relationship between the JDK, JRE, and the JVM. But every good answer just leads to a new, more interesting question, doesn't it? Like, what's really happening inside that little engine, the JVM? How does it actually manage memory? And what in the world is a just-in-time compiler, and how does it make your code run faster? Well, that sounds like a story for another time. Thanks for joining this explainer.